Good morning, everyone. It's my pleasure to welcome you to the webinar that we have on navigating maritime decarbonisation between IMO and EU policies. In this webinar, VTT will present REFOLUTION insights and frame the discussion on EU and IMO developments. REFOLUTION is a EU project that is currently ongoing. I will leave it to the first speaker to give a proper introduction of the project. So in the meantime, I will go ahead and share the agenda. So this is a 1-hour webinar. We will start with Silvia from VTT, who will give us some insights in what are sustainable biofuels and give us some relevant indicators that can be used for policy and stakeholders. Next, we have an EU update where Tom Walsh will give an overview of FuelEU, Maritime and relevant regulations and developments in this sector. Then we will hear some recent marine fuel innovations from VTT. And we will, the final speaker of today will be Matteo Prossi, who will give us some updates on policies and implications for alternative fuels. In the end of this webinar, we have a Q&A session. So I would like to ask those of you who have questions to do that in the Q&A alternative on the Zoom. So do not use the chat button, but the Q&A button, and we will collect all the questions and we will try our best to answer that towards the end of the webinar. So by that, I would like to introduce the first speaker of today, which is Silvia Forin from VTT. She's a senior researcher and she specializes in life cycle sustainability assessment methods, such as life cycle assessments for products and organization, water footprints and carbon footprints. So I will leave it to her to give some insights into the REFOLUTION project and what they've been working on for the sustainability of biofuels. So thank you, Silvia.
Yeah, thank you, Celia. Thank you very much for a nice introduction. And welcome to the first part of the webinar. My name is Silvia Forin from VTT, the Technical Research Center of Finland. And together with my colleagues from the VTT Sustainable Business Team, we investigated as part of the REFOLUTION project, what are the most relevant sustainability aspects for biofuels from a policy and industry perspective. First of all, a couple of words about REFOLUTION. REFOLUTION is a Horizon Europe funded project and stands for Refinery Integration, Scale Up and Certification for Aviation and Marine Biofuel Production. The idea is to promote biofuel production in existing refineries using forest residues for the production of pyrolysis oil and using co-FCC or HDO for fuel production. These processes are tested in the project at the lab scale, pilot scale, and demonstration scale. And these different steps of production development are reflected also by the different project partners that are involved. A total of 14 stakeholders, universities, research and technology organizations like VTT and SINTEF, startups, and also established players in the field, for a total of 8 EU countries represented. The advanced biofuels developed in REFOLUTION are expected to have significant impact on sustainability, enhancing circularity and social acceptance of biofuels. And the quantitative targets are to reduce the CO2 footprint by 60% and making advanced biofuels more cost effective by 50%. VTT, in our work in REFOLUTION, we supported these targets. And first of all, we engaged in a responsible research and innovation process in which we involved the societal stakeholders through information events. After this, our more technical work refers to the calculation of the environmental impacts of the developed biofuels, which serves also as an input for the creation of sustainable business roadmap for advanced biofuels. But which environmental aspects should be accounted for when we talk about sustainable fuels? Or put another way, what is biofuel sustainability? To find this out, we asked the REFOLUTION project partners, we asked company stakeholders, and about their perception on regulations and on environmental aspects that are relevant in this sector. Looking at regulations, the stakeholders perceived a strong focus on global warming potential, so on climate change impacts and on land use change. But they perceived also a very diverse regulatory landscape, which would need some harmonization. The main environmental aspects, according to the stakeholders, beyond GHG emissions, are particulate matter, water use, biodiversity, land use efficiency, and impact on arable land, energy consumption, and biogenic carbon. Stakeholders also identified as very important to have available sustainability data, both in secondary databases, but also to use primary data to depict specific processes. In the project, we also analyzed different regulations. The first one is the FuelEU Maritime regulation. We will hear more about also later. This regulation is dedicated to renewable and low carbon fuels in maritime transport, and it aims at reducing the energy intensity in this sector by 80% until 2050. It addresses also methane emissions and nitrous oxide emissions in addition to CO2 emissions. And it provides default values for well-to-tank and well-to-wake emissions calculations. So yeah, from a sustainability point of view, it has a strong focus on climate. We analyzed also industry standards on the biofuels from the International Maritime Organization. The first one is the strategy on reduction of GHG emissions from ships, which provides guidelines on life cycle GHG intensity measurement and calculations, a sort of SCA guidelines, and focuses on GHG emissions, the sustainable sourcing of biomass, and sustainable water usage. And it also explains that sustainable biomass shouldn't be sourced from land with high carbon stock, such as primary forest, wetland, or peatland. The newest framework is the IMO Net Zero framework, which was approved last year, but will probably enter into force only in 2 years. And it introduces a new global fuel standard that requires ships to decrease their fuel GHG emissions. And an important thing is that emissions are measured across their whole life cycle. Besides very specific regulations and standards, we considered also sustainability legislation in general and which role biofuels have. We had a look at the Renewable Energy Directive, the last one, number 3. And it establishes a life cycle GHG emission saving criteria for biofuels and acknowledges risks such as land use change, deforestation, biodiversity loss, and risks to food security. Important is also the EU regulation on deforestation-free products, which establishes a sustainability criteria relevant for biofuels, bioliquid, and biomass fuels produced with forest biomass, which is the case also in the for the REFOLUTION project. It explains that there shouldn't be damage to biodiversity, soil quality, long-term production capacity, and guarantee forest regeneration. And it sets also a privilege for advanced biofuels from forestry waste and residues. It has also some social compliance targets and also governance related criteria, such as the consideration of land use rights, forest management, human and labor rights, and the rights of indigenous people. The very last policies we had a look into are the EU taxonomy and ETS. In the taxonomy, for the use in transport, biofuels can meet the substantial contribution criteria for climate mitigation if no food and feed crops are used and 65% GHG savings are realized, and do not the sustainable harm criteria are met by default for climate adaptation, water, and biodiversity. In the looking at the EU ETS, the maritime sector is fully integrated since 2 years now, and tank-to-wake CO2 emissions are considered, and from this year on, also methane and nitrous oxide emissions will be taken into account. After this analysis, we provide a tentative selection of environmental sustainability aspects that need to be taken into account when talking about biofuels. And these are water scarcity, climate change, biodiversity loss, and land use change. These were our first insights. Thank you very much for your attention. And if you have any questions, I will be glad to reply in the final part of the webinar, or you can use the Q&A function for this. Thank you very much.
Thank you, Silvia, for a very nice presentation. And as she mentioned, please use the Q&A button at the bottom of your Zoom screen for any questions, and we will follow up towards the end of this webinar. We've come to our second speaker of today, which is Tom Walsh. He's a national coordinator for the IEA Bioenergy Task 39. He is also a founder of Renetech AB, a company that develops sustainable and environmentally friendly renewable energy projects. And today, Tom will give a presentation where he will give an overview of the FuelEU Maritime and relevant regulations and developments in this sector. So please, Tom, if you would like to share your screen.
Okay, you can't see it yet, no?
No.
Okay, second.
See a nice video of you, though.
Okay, thank you.
There we go.
Yeah, you have it now, have you?
Sorry?
You have the slide, yeah?
Yes, and it's in a
okay,
good
thank you very much,
mode.
Silvia. That was very nice, and thank you to Silvia as well for her nice presentation. So, as was mentioned, we're part of the Task 39 IEA Bioenergy, which is focused on biofuels for decarbonisation of transport. And just to mention there, as you see on the first slide, We did release a report last year, which was focused on lowering the hinders for the implementation of maritime biofuels in the maritime sector. So that's downloadable on the IEA Bioenergy Task 39 site. So I suppose just to put a bit of context, you know, we are aiming to get to net zero by 2050, and the maritime sector, 40%. We should bear in mind that 40% of all the products that are transported in shipping are actually coal, oil, and gas. So as we increase the energy efficiency levels, and as we use alternative fuels, we have a double effect in terms of the greenhouse gas reductions. Just to put it a little bit in context, you know, we're working right across the value chain, all the ways from the feedstock, and there are different feedstocks around the world that are inputs to different types of biofuels, particularly for the maritime sector, and they have different availability and volume and seasonality. Certain regions like Brazil and the US will have very high production of bioethanol, and indeed also biogas and biomethane. But in the maritime sector, we are talking about a multi-fuel environment in terms of the implementation, and I'll talk a little bit later about that. We also have to consider the production, the feedstock logistics, the regional demand, and the bunkering issues, because you know not every port bunkers ships. So all those things have to be considered in terms of import and export, and also different competing uses, because biofuels are used in the heavy duty sector. They're also used in sustainable aviation fuel. So we have to consider the availability and scalability issues, and obviously byproducts. And then finally, in terms of use, maritime sector, different engine types. So you can use drop-in fuels. You have LNG ships that are geared towards the biomethane environment, but you also have heavy-duty fuel oil, which is more considering the drop-in fuels. So the maritime sector has a limit on the greenhouse gas intensity from a well-to-wake basis on board the ship, staying within or departing the ports from the jurisdiction of an EU member state. And this is something that has been introduced in 2025. We're now actually currently in the vessels are currently in the reporting phase, or they have been in the reporting phase, and they're doing their final compliance. I think the final for the first year for 2025, which has to show a 2% greenhouse gas energy intensity reduction. The final reporting will be in the March-April period. There's also an obligation for onshore power supply that, you know, in terms of wind or solar electricity production, fuel cells or batteries. So that's also something that people actually have to consider from an implementation perspective. The eligible maritime fuels are biogas for transport, and then biofuels produced from feedstock listed in parts A and B of Annex 9, and renewable fuels of non-biological origin, and recycled carbon fuels. So low carbon fuels. And then as we're moving towards the intermittent targets, the targets increase progressively to 2030, etc., 35, 40. So there's different targets as we move along. Non-compliant fuels and food-based biofuels are considered to have the same emission factor as the least favorable fossil fuel. There is a pooling mechanism in the FuelEU maritime regulation, which allows vessels to share their compliance balances, redistributing surpluses and deficits. So as you see at the end of the slide there, from a simple example, is if one vessel has a surplus of 100 tons of CO2 and another vessel has a deficit of 90 tons CO2, they can combine the two vessels and make those vessels compliant. This is showing it in another format, that if there is a ship that is running on liquefied biomethane or liquefied heat, can provide compliance for 36 to 45 vessels that are running in LNG, or a similar figure for HFO is heavy fuel oil is 32 to 40. So this is what a lot of the vessel owners and fleet owners are working with at this particular point in time. And those fleets can go across different owners of fleets in order to meet the compliance. And then, of course, we have to consider what is an advanced biofuel as well as part of the energy directive. Different feedstock types as listed in Part A of Annex 9 of the Renewable Energy Directive. This is mainly includes lignocellulosic material, non-food crops from severely degraded lands and intermediate crops. Then also residues like residues, animal manure, sewage, sludge, and different types of wastes and residues, which obviously would be going into the biomethane value chain. So, and then we can also consider feedstocks in terms of used cooking oil and category 1 and 2 animal fats, which would be coming from the rendering industry and also the cattle industry, sheep, pigs, etc. But this is limited to 1.72%. In terms of the multiplier effects, renewable fuels of non-biological origin in both the aviation and maritime sectors, they do have a multiplier effect of 1.5 in the case of the maritime sector. They're renewable fuels of non-biological origin, and this is also a factor which is under development now. Probably we would consider it's in terms of beaker to bucket to barrel to bunker. It's probably moving into the barrel area with lots of project development happening for different facilities, and the combination of hydrogen and biogenic carbon. We can see that particularly in the methanol area, green methanol, that is an area that's developing quite rapidly. Jen, just to maybe taking those regulations into account, I think it's important to remember that this is kind of a size of production and size of innovation scale for the maritime sector. It's beaker to bucket to barrel to bunker, and obviously the bunker area, you don't have that in every port. So some vessels are, and I'll explain that a little bit later as well. Some vessels, a lot of it happens in particular ports where the bunkering actually happens. And, in the maritime sector, we're using 300 million tons of fuel on an annual basis globally. We need something like around 30 million tons of alternative fuels by 2030. So also, we should bear in mind that in terms of green intensity, greenhouse gas reductions, energy efficiency is an important factor in terms of IoT, green corridors, and also slow steaming, etc., all of which reduces the usage of fuel and can actually make the vessel compliant. There is still a lot of research going on in the beaker to bucket area. This is particularly like e-fuels and so on, but also other fuels. Bioethanol is not used extensively in the maritime sector, but it is obviously in terms of scalability and availability, it has huge volume. So just to mention some of the areas to look at from maritime biofuels perspective, you have sustainability, scalability, and availability. or sustainability, availability, scalability, the SAS framework, and this typically is being implemented in the form of green corridors. And just to bear, these are the largest ports in the world. Singapore does about 50 million tons. It accounts for a sixth of all world maritime fuel. There's a very interesting case study in the report that we produced there. They have adopted all of the fuels, including ammonia, etc., and have run ammonia trials in 2025. So I'll just maybe just say to conclude here is that the green corridors are an implementation mechanism in terms of getting more green transport, and there are green corridors already implemented which are moving from Singapore to Rotterdam and other areas. And this is a good mechanism to allow both the use of energy efficiency measures and alternative fuels from an implementation perspective. So I know I had to run through that quite quickly, but thank you very much for your attention, and I'm happy to take any questions later on in the webinar. Thank you.
Thank you, Tom, for this very nice overview. I'm sure there will be questions for you towards the end of this webinar. But I think we will move on to the next presenter. For the next presentation, we have two presenters, both from VTT. We have Juha Lehtonen, who is a research professor in bioenergy and thermochemical processes. He has large experience in petroleum refining industry and also in biomass conversion into chemicals and fuels. The other speaker from VTT is Päivi Aakko-Saksa, who is a principal scientist at VTT with more than 20 years of experience in energy research and propulsion systems. So together they will give a presentation on recent marine fuel innovations. So I think I will give the word to Juha to start, and they will share the presentation. Right. So if you can go ahead and share, Juha.
You actually, it is Päivi's part which will come there first, but I will share anyway the presentation.
Okay, good day. From my side, I'm Päivi Aakko-Saksa from VTT. And next slide, please. I'm talking about methanol in marine use. So next slide, please. To start with, let's see of the whole picture, what is happening in fuels used globally, and then what is needed in maritime sector. And today, fossil fuels are produced, composed quite much of methane. If we think about these alternative fuels, so methane is the dominating fuel. And this includes also biogas for energy production. And then if we look at the current bio and electrofuel production volumes, there ethanol is dominating with 84 megatons produced. And then FAME, biogas, and then renewable diesel. And ammonia and hydrogen are almost non-existing, while methanol is relevant at around 8 megaton production volume. And the prospects for the 2030, they are quite huge when compared to the current volumes. So especially for ammonia and hydrogen. So they should grow really fast. And what is used today in maritime fuels, the biofuel that is used most is biodiesel and renewable diesel, but less than 1 megaton. So that is not much. But the production potential is really huge for biofuels and electrofuels. For instance, biomethane could be produced around 720 megatons. But the progress is slow, so they are not produced in sufficient quantities. So something radical should happen so that the production would grow. There is a clear sink in Maritime, which uses around 2010 megatons of fuel. So next slide, please. And when coming to methanol, I would show you one innovative process to produce methanol in combination with methane. So there was Up2Me project led by VTT, which got funding from Horizon call for breakthrough technologies. And here is an example of a process where biogas is produced from a wastewater treatment plant, but it could be any biogas. Biogas contains around 20% of CO2, and in this concept, methanol would be produced from the CO2. And this concept was autonomous, self-optimizing, and compact technology. So next slide, please. And what comes to methanol use in maritime, everything is ready. So the fuel standard, including 3 different methanol grades, was published in 2024. So ISO 6583. And here, the most relaxed grade MMC would be interesting for e-methanol, since then we could save some distillation costs when allowing a little bit more water in methanol. And the question is whether this how this impact on the usability in engines, but then we believe that the processed water would not indicate necessarily the impurities, which are typically coming from seawater in transportation. And a lot of ships that are ordered today, 9.7% of the tonnage ordered are already methanol ready. And Wärtsilä and MAN covers the large ship engines very well. So engines are available, and then Enmar engines have a retrofit and single fuel concept for small vessels, and also the dual fuel retrofit concept. Next slide, please. And in this Up2Me project, there was e-methanol produced sufficiently so that we could demonstrate it. We did use high-speed engine from Enmar engines dual fuel kit. So this was a kind of prototype of Volvo engine, and then Volvo Penta, and based on the port fuel injection technology. So there are also better concepts if modern diesel engines would be used for retrofitting. But we could achieve 40% replacement of diesel fuel with this concept, and this e-fuel performed well. But to note, the exhaust emissions from this type of engine were so high that exhaust after treatment is necessary, and the regulations should still meet this challenge and take this into the account for these smaller segment engines. So this was a plans on this e-methanol pathway for shipping, and so I will give floor to you, Juha, now for other aspects.
Thank you. Can you hear me? Obviously, yes.
Yes.
Yes, so I will tell pretty much, this is very pretty close to the topic of REFOLUTION project as well. So kind of the one pathway from liquefied biomass to marine fuels, and in general going to the topic. So there is many ways to liquefy the biomass, and there is 3 maybe main pathways: the fast pyrolysis, catalytic fast pyrolysis, and hydrothermal liquefaction, and in all of those, there is, for instance, a lot of oxygen still left after the liquefaction, and I would say that in general they are quite far from any transportation fuels still. But on the other hand, also there has been a lot of difference between those different bio-oils and bio-crude with fast pyrolysis oil with highest oxygen content and hydrothermal liquefaction. Bio-crude typically the lowest content of oxygen there, and of course many kind of organic molecules with oxygen, then making them very complex mixture with challenging properties. That will mean that also the upgrading is typically pretty challenging. So we are facing their thermal instability of the oil causing catalyst coking, catalyst poisoning, even blocking of the reactors and so on, which makes it challenging, and therefore I think that kind of standalone hydrotreatment upgrading of bio-oils has not been really yet commercialized to reach kind of the qualities of transportation fuels like marine fuels. Slurry hydroprocessing is a technology we have studied and proposing for that, and in that actually we are replacing in that first upgrading step, which is most challenging due to the instability of those oil. There we are replacing fixed bed reactor technology with kind of the slurry reactor technology, where finely dispersed catalyst is continuously added and removed from the reactor, and that enables that we can kind of all the time add fresh catalyst and remove spent catalyst from the reactor, and in that way it's kind of the handling that kind of the deactivation related challenges. After that we get pretty stable oil because we can do that first stage upgrading at relatively high temperatures with relatively low oxygen content already, and then the rest of the upgrading can be done with using kind of traditional fixed bed upgrading to reach kind of the transportation biofuel qualities there. So what we have done is we have had a lot of catalyst development for this slurry hydroprocessing upgrading, and also in cooperation with our partner RISE, then done kind of the proof of concept with our catalyst there to kind of show that is kind of the working way to treat those challenging bio-oils. In this case we had fast pyrolyzed bio-oil there as a feedstock, and in that 70 hours run we managed to more or less remove half of the oxygen, even much more of that, so ending up with kind of the intermediate which was stable and having oxygen left 10 to 15% there. So that's still an intermediate, so that requires further kind of the treatment before it can be used as a transportation fuel. For maritime use, maybe it's allowed that a few percent there is still oxygen left, but in this case we aim to really low oxygen content of the final product. So more or less we then next step we did, we used that or utilized that intermediate from slurry hydroprocessing, that oil from there, and second step upgrading by fixed bed hydrodeoxygenation using some sulfide typical refinery IMO COMO type catalyst there, reached their pretty high hydrodeoxygen degree of deoxygenation, close to 100%. Also quite high conversion of HDN there reached there, even though there is very little even nitrogen left when feeding that fixed bed hydroprocessing. What else? Hydrogen consumption is kind of the indication how efficient that upgrading is, and it seemed to be that it's always also quite stable, indicating that no significant deactivation was observed during 160 hours of time on stream there in the system. But anyway, let's look what we got there. This is kind of the distillation curve of that oil product after two-stage upgrading there. First of all, on we can see on right hand side that the density of the fuel is a bit over 0.8 there typically, and it was kind of reduced in the upgrading significantly there. On the left hand side we have the distillation curves of the product there, and of course there is no boiling point. exact boiling point range given for the marine distillate fuels, but thinking about flash point and other kind of constraints which are there. So I would say that about 50% of that oil product would fall into the range of marine distillate fuel. What comes to the kind of the boiling point range there. So the rest of that is of course we have about maybe 40% there lighter, so mainly then some is classified gasoline or maybe naphtha, or then some heavier residue maybe could be used for the residual fuel, but here we look how it fits to the distillate fuel. So far we have mainly looked the oil product from that point of view that we would produce aviation jet fuel. So therefore for this we distilled the product to the range of jet fuel more or less, but we are going to look more the properties of the oil for the marine fuel. But as you can see, what we got is kind of the pure hydrocarbon fuel with very low sulfur and so on, and very nice cold properties and so on. So I would say that it's pretty good fuel as well for the marine distillate fuel, that fuel which we got there. And finally, it's interesting to look what it happened in kind of that up two stage upgrading. So if you think about that, we have 100% bio oil, how much it is ending up to the fuels, and on the right hand side actually we see the mass balance, and then on left hand side the mass balance, and right hand side the carbon balance. And of course in mass balance we have to take into account that there is about 40% water in the bio oil, so we get a lot of aqueous phase there, over 50% of the mass balance. So of course therefore it is pretty low amount which ends up to the oil products, about 33%. Here we have looked that produce first SAF and from the rest then marine fuel, to think about combining that SAF and that other products there in the sunk area diagram, so you can think about that maybe 20% of the bio oil mass would end up to the marine fuel. If you look carbon balance, it looks much better because the water has not been taken into account there, and that will say that around 60% of the bio carbon will end up to the oil products. And again, we have primarily looked here at the sustainable aviation fuel, but if forgetting that, so could maybe say that 30% of the carbon of the bio oil could end up to the marine distillate fuel then. But very interesting results, and we are continuing work here in many projects. These results are mainly from Circular Fuels EU project, but work is ongoing in REFOLUTION and many other projects as well. But I think that was more or less all I was thinking to present today. So thanks for your attention.
Thank you, Juha and Päivi. There are already some questions in the chat or in the Q&A that we can answer after the next presentation, but please continue to ask questions, and thank you for presenting us and giving these results, both Juha and Päivi.
Thank you.
So I'll go to the next speaker, who is Matteo Prossi from Politecnico University of Torino. He's an industrial engineer with a scientific background in renewable energy conversion technologies. So, and he will give a presentation where he will update us on policies and implications for alternative fuels. So when you are ready, Matteo.
Struggling to switch on. Good
there
morning.
You are.
Thank you.
Good morning,
Thank you
Matteo.
very much for the invitation, and it has been very interesting listening to all the colleagues so far. I hope you can see my screen and
I only see a black screen. I think I saw your screen earlier, but it disappeared. Let me. There you go. Yes.
Oh,
thank you.
Okay, so in order to save time, let me navigate quickly through the introduction. I mean, to put a bit of background on justifying why I'm touching on some of the points. Well, Polito, in particular myself, but also Professor Chiaramonti is deeply involved in the development of a part of the legislation which has to deal with the alternative fuel sustainability aspects. And in particular, I am co-leading the core LCA group in the ICAO Corsia exercise, and somehow for that I am also nominated as a member of the GAZAMP WG 46 on LCA for the marine fuel LCA work, let's say, assessment, the streamline of the LCA guidelines of the IMO. And this is really the core of what I would like to present today, in the sense that, as you know, IMO revised the strategy in 2023, basically setting some key objectives like the reduction of the carbon intensity of the ships through several instruments, I would like to say. The reduction of the overall carbon intensity of the transport, with a target for reduction of about 40% in 2030, and with the ambition to have what I typically call a waypoint of around 70% in 2040. But again, the real discussion today is about the net zero framework. So the possibility to really reach in 2050 the net zero for the sector. I said the discussion is ongoing because the MEPC that revised the strategy in the MEPC 80 then continued the discussion and proposed a net zero that was initially approved, but then in the October, sorry, there is a typo here, 2025, some members of the MEPC opposed basically the current structure, and therefore the discussion was entirely postponed to 2026. So we are leaving a kind of transitional period in terms also of clarity for the operators with respect to the overall target. And this is clearly a relevant point for people that need to invest in the short term. And this is clearly linked to the role of the alternative fuel for marine fuel, in the sense that with respect to the need of decarbonizing the sector, every single study available identified clearly alternative fuel as a mean to enable this transition. And this with respect in particular to the greenhouse gas reduction potential. So the greenhouse gas reduction is I would say, the key driver for considering alternative fuels into the system. And again, with respect to the need of decarbonizing the sector. In my presentation, what I would like to stress is that we are living in what I typically define a policy-driven moment of the transition, in the sense that only policy can really support the transition in order to, through instruments that allow to close the gap that today exist with respect to traditional fuels, and this in terms of costs, availability, infrastructure readiness, etc., etc. There are clear gaps that needs to be covered, and policy is market per se will not solve as of today. And I will show you some example in terms of costs, for instance, the issue. To that extent, it's key what MEPC endorsed. I mean, the guidelines for LCA of maritime fuel, because again, the driver is the greenhouse gas saving, and the reason why we are basically one of the most relevant so far elements of considering alternative fuel into the system for the transition of the sector, and therefore having a tool to clearly demonstrate these advantages and to allow operators to be able to calculate the carbon intensity of each batch of fuel. It's a key element of the discussion. And again, IMO endorsed the LCA guidelines that basically is without entering, we don't have time and possibly is out of the scope of this event, but without entering into the details, is a well-to-wake approach what has been adopted by the IMO. So we have a part that is purely related to the fuel that is called well to tank. I mean, from the feedstock cultivation up to the bunkering of the fuel. And then we have the uptake into the ship, into the vessel, where the tank to wake, so the part related to the efficiency of the ship is related to. The overall effect is what it counts. So the combination between the fuel and the innovation related to the ship fuel usage in particular, if we talk about alternative fuels for the sector. Again, in order to stay on the time that has been allocated to my intervention, here there is a study we did as a Politecnico last year, basically, in which we compare the greenhouse gas saving using a tool that we have in the Polito, but I mean leveraging upon relevant study like the GEC, the JEC study version 5, rather than the Renewable Energy Directive, in which we gather information about the potential saving of various bio and E alternatives, so power to liquids, I'm referring with E. And we put this information together with the costs. Again, you see in this graph the cost in euro per gigajoule of the fuel, and you see like with the gray and blue dots, dotted line, the very low sulfur fuel oil and MGO, how it's difficult as of today to cover the gap, the existing gap between the existing alternative solution with respect to the fossil typical fuel that is used. And that's the reason why I started discussing about the policy-driven moment, because the market per se won't be enough to close this gap. And this is particularly relevant even for the biofuels, but more if we move toward the e-fuels. And this is an exercise I always do and I like a lot. If we put together the greenhouse gas saving potential, which is the gram of CO2 we save per megajoule, with the cost in euro per megajoule, what you get is the euro that is required to save 1 ton of CO2, so to achieve the goal in a decarbonization scenario. How much does it cost for the different solution? And what you can see here is that basically there are options, and here is the well-to-wake analysis. So the cost without considering the retrofitting of the ship. So it's missing a large part of the discussion, but it's the first results you get when you compare the biofuel used in certain type of engines. And as you see, the green solution are the bio and the orange are the e-fuels. There are few options that today provide saving at a reasonable cost. And what we got is a confirmation of what we have observed in terms of interest by the industry, and namely the biodiesel option, but lower than the biodiesel is the biomethanol and the ammonia. That is the only e-fuels that might result competitive with the bio alternative if we don't consider the need of retrofitting the ship. So it's where a large part of the discussion is missing. But again, I rushed a bit, I'm aware of it, but in 10 minutes it's very challenging to present the status of the policy and how the policy are working today to do what? Basically, to enable the transition, because somehow I would say that the target is clear. What is not necessarily clear, it's the pathway forward. This is not fully true for the European regional context, where the FuelEU Maritime allowed to have such kind of vision in terms of pathway, while in IMO there is a strong discussion on how to reach the targets. Clearly, however, the alternative fuels are a solution, or better, are part of the solution, which is the problem that today cost is the main gap. Is not the only one. For some alternatives, we need also to talk about infrastructure that, however, can be then understood through the final cost for an operator of taking a certain solution, adopting a certain solution. And therefore, policy support is absolutely needed in this stage. And it's where I want to stress and close my presentation saying that if the target is there where we have to navigate. So where island, it's fairly clear. If the path is not clear, it's difficult to see in the real world investment materializing, and we really need to increase investment in alternative fuel sector if we want to have real volumes in the market, because there is a gap between the potential demand and the potential in terms of production as of today. And with that, I would like to thank you again for the invitation and for your attention.
Thank you, Matteo, for this very nice overview. Nicely done work. I think we will move on to the Q&A session. I can just say that all the presentations will be available through the REFOLUTION webpage, and also that the presentations have been recorded, and you can access those in the YouTube channel. I think we'll start with some questions for the speakers today. So maybe I can start with the question to Tom. There's a question here. Could you explain how the multiplier effect for advanced biofuels will be implemented and how you anticipate it will be accounted for projects?
Yeah, thanks very much. I think, I mean, in terms of compliance and reporting, it's happening at the fleet level and the vessel owner level. So in terms of the various biofuels and the multiplier effect, it'll be in that compliance mechanism and based on the greenhouse gas reductions that they actually receive. I mean, in different member states, I know from in the case of Ireland, for example, not now in the maritime sector, but actually in the case of regular transport fuels, there are some fuels that they use a certificate mechanism, and in the case of biogas for waste, which is considered as an advanced biofuel, it gets 2 certificates. But you know, they're just working now with the actual first compliance round and the first reporting round, which they're closing out. And there is a requirement for third-party verification. So I'm not sure it'll be the projects that will be doing the reporting. Is actually happening at the vessel level and the actual fleet owner level.
Thank you, Tom. We have just a couple of more minutes for questions. I think there's one that I think maybe Matteo can answer. Is the IMO considering the use of first-generation bioethanol as an option for decarbonizing the maritime sector?
Well, to give a quick answer, I would say so, in the sense that the first generation pathways are already part of the initial list of fuel in the annexes of the LCA guidelines. And as Gazamp, we already reviewed some inputs. So to cut a long story short, yes, I think the approach is the same that we, at international level, we have also for CORSIA, in the sense that as long as the certification process proves that you are sustainable in your production, given the sustainability framework that has been defined, there's no preconceptions about the feedstock that you use. So yes, I would say that first generation is potentially eligible. And
thank you. Then we have a question for VTT. I think this was from Juha's presentation. At what scale will the slurry reactor system for hydroprocessing and bio-oils be economically feasible? And do you anticipate any issues with scaling up this type of system?
Yes. So far, I think we are mainly working in pilot scale. So of course, there's still issues regarding the scaling up. We are also going to get kind of the corresponding system which RISE is having, but a bit smaller one, what we did to kind of enhance research in that field. But yeah, I would say that it's anyway kind of the hydroprocessing units, also maybe relatively big scale units are preferred there over maybe 100 kiloton, and even more so maybe collecting then bio from many liquefaction plants, then yeah, and there is still issues regarding the scaling of, for instance, what kind of the reactor technology is to be used in the larger scale. But we are currently kind of we have ongoing projects on that topic, and also still looking kind of the fundings for more to look in more detail those questions and continue kind of the scaling up of the technology.
Thank you very much. I see we've come to the end of the webinar. There are still some questions that are left unanswered. So if the presenters can have a look in the chat and see if you could follow up on some of them, that would be great. Thank you very much to all the presenters for sharing your work and your insights into these topics. Much appreciated. And yeah, I can also confirm, I see from my colleagues here that we have marked the questions, and we will prepare a post on LinkedIn where we can answer the ones that we didn't have time for today. But thanks again to all the presenters, and thank you also for joining this webinar. The presentations will be available on the REFOLUTION webpage, and until next time, have a good lunch, everyone.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you.
Bye. Thank you.